Today, we are going to discuss about impulse. What is your favorite ball game? Most of the boys would like to play basketball. How hard is it to stop the ball from moving? If the ball is kicked and attains a great momentum, it will be difficult to stop. Now, consider a pitcher and a catcher. In a baseball game, who exerts the greater force, the pitcher or the catcher? And how can this baseball be stopped? What is the effect of force and time to the motion of the object? According to Newton's second law of motion, an unbalanced force causes an object to accelerate or decelerate or even stop. To stop an object, we have to apply a force over a period of time, and this is called impulse. The change to a body's momentum caused by a collision is called impulse, measured in Newton second. Impulse is a vector quantity, meaning it is with magnitude and direction. Impulse also refers to a change in momentum. And in formula, we have I is equals to F times T, where I is the impulse, F is the force, and T is the time. But we know that F is equals to ma from Newton's second law of motion. Therefore, we will replace our F with ma. And so our formula now will become I is equals to mat, where our A, according again to Newton's second law of motion, is equals to V minus VO over T. So we will replace our A here with, V minus VO, this one, over T. The formula now will become M times, instead of A, we will place there V minus VO over T times T. Then we can cancel out the variable T. So what is left is I is equals to M times V minus VO. But we know that V minus VO is equals to delta V. So therefore, we can replace our formula with I is equals to M times delta V. So this now can be our formula. Again, I is equals to M times delta V. So I is equals to M times, we know our delta V to be equal to V minus VO. If VO is 0, because the object is at rest, then I is equals to M times V. But we know that our M times V is equal to P. So therefore, I can be equal to P. It can also be mathematically expressed as I is equals to F times delta T, where I is the impulse, delta T is the change in time. And we know that I is equals to P. And I, from the equation above, is equals to F times delta T. And from the previous slide, we know that P is equals to M times delta V. So we can also have our formula as P times delta T is equals to M times delta V. Let us try to take a look at this given example. Work that on your own and check. The force given here is letter A, 34 Newton, and the time is 0.027 seconds. Identify what the impulse is. Letter B, the force is 91 newtons, and the impulse is 187.005 kilogram meter per second. What is the time? Letter C, our force is 128.95 newtons and the time is 0.76 seconds. What is the impulse? Letter D, our force is 29 newtons and our impulse is 87.99 kilogram meter per second. What is now the time? And letter E, given the time to be 1.72 seconds and the impulse to be 22.36 kilogram meter per second, identify what the force is. Okay? Given the force to be 34 newtons and the time to be 0.027 seconds, our impulse is computed to be 0.918 kilogram meters per second. Letter B, given the force is 91 newton and the impulse is 187.005 kilogram meters per second, our time is computed to be 2.055 seconds. Letter C, given a force of 128.95 newton and the time to be 0.76 seconds, our impulse computed is 98.002 kilogram meters per second. Letter D, our force is 29 newtons. Our impulse is 87.99 kilogram meters per second. Doing some computation, our time is 3.03 seconds. And letter E, given the time to be 1.72 seconds and our impulse is 22.36 kilogram meters per second, our force is computed to be 13 newtons. You got it right? So that's job well done. Now let's try to take a look at this sample problem. A 430 kilogram tricycle is traveling at 30 kilometers per hour, slows down to 10 kilometers per hour in 5 seconds as it approaches a road intersection. What is the force applied on the brakes of the tricycle? What is the impulse exerted on the vehicle? Let us now solve this problem using GAFSA. The first given you will see is 430 kilogram, that is the mass. Then another given is 5 seconds, that is the time. Another given is 30 kilometers per hour, which is the initial velocity. Then we are also given 10 kilometers per hour, that is the final velocity. Now take a look at the units of velocities here. It is in kilometers per hour. Our unit of velocity should be in meters per second. So we are going to do conversion. Now, we can make use of the conversion factor. 1 kilometer is equals to 1,000 meter and 1 hour is equals to 3,600 seconds. Now multiply this 30 kilometers per hour with the first conversion factor. Arrange your conversion factor in such a way that you can cancel out units. So we will have here 1,000 meter divided by 1 kilometer. The purpose why we are going to place 1 kilometer below is so that we can cancel out the unit kilometer. Then multiply this with the second conversion factor, that is 1 hour is equals to 3,600 seconds. Do the same, we can cancel out hour, and what is left is the unit meters per second. Doing your calculation, it will turn out to be 8.33 meters per second. Do the same with the other velocity. Multiply this by the first conversion factor. 1,000 meter is equals to 1 kilometer. Then cancel out the units. Okay. Now, after which, we are going to multiply this with the second conversion factor. 1 hour is equals to 3,600 seconds. And cancel out the units hour. What is left now is the unit meters per second. And doing calculation, this will come out to be 2.78 meters per second. What is being asked in this problem is the force and the impulse. So, the formula that we can use is Ft is equals to m times delta V. And the other formula for the impulse is equal to I equal to Ft. Now, let's try to solve the first question. Ft is equals to m times delta V. That's our first formula. Substitute the given. We can now have F times the time, which is 5 seconds, is equals to 430. That's the mass multiplied by 2.78 meters per second minus 8.33 meters per second. These are the velocities. So F then is equals to negative 2386.5 kilogram meters per second divided by 5 seconds. It will turn out to be negative 477.3 Newton, meaning it is in the opposite direction. Now, solve for impulse. I is equals to F times T. Our F is negative 477.3 Newton multiplied by 5 seconds. It will turn out to be negative 2386.5 kilogram meters per second. That is now our impulse. Let's have another practice problem. A 57-gram tennis ball falls on a tile floor. The ball changes velocity from negative 1.2 meters per second to positive 1.2 meters per second in 0.02 seconds. What is the average force on the ball? Let us now try to solve this problem using GAPSA. The first given you will see is 57 grams. That is the mass. Now take note the unit here is given in grams and our unit of mass should be in kilogram. Therefore, we are going to do conversion here. We will make use of the conversion factor that 1 kilogram is equals to 1,000 grams. So we will use that, arrange it in such a way that your unit gram must be cancelled out. So our denominator then would be 1,000 gram and our numerator is 1 kilogram. Cancel out units. So what is left is, if we cancel out grams, what is left is kilogram. And that is equivalent to 0.057 kilograms. Then, another given is the velocity initial, which is negative 1.2 meters per second. And another one is velocity, which is positive 1.2 meters per second. This has different directions, that is why it is denoted with the sign. Then, the time is 0.02 seconds. What is being asked in this problem is the force. Now, our formula for the force will be F times delta T is equals to M times delta V. Substitute the given. We have here F times 0.02 seconds, that's the time, is equals to the mass, that's 0.057 kilograms, times the velocities, that is 1.2 meters per second minus negative 1.2 meters per second. Simplifying, we will get F times 0.02 seconds is equals to 0.057 kilograms times 2.4 meters per second. That will turn out to be equivalent to 6.8 kilogram meters per second square or 6.8 newtons. Okay. Synthesizing, we know that impulse is a vector quantity. It is related to impact. The impulse exerted on an object depends on the force acting on the object. Impulse is directly proportional to the force. The time that the force acts. Impulse is directly proportional to time. That's all. Thank you and have a good day.